In this game dev course, Varnos Games will teach you how to build games with Unreal Engine 5. You will also learn how to use the Blueprint visual scripting system that makes it simpler to create gameplay elements.
Hey guys, thank you so much for checking this course out. This is going to be a very beginner level Unreal Engine 5 Blueprints only course. We're going to make a simple game called the Battery Man. So if I play this game, what's going to happen is I have a few batteries present all around the scene. I have to collect these batteries over here. And once that's done, I either go to the new level or I win the game. So here, this is my second level. And if I collect these batteries, I have my win condition, and I always have a lose condition too. So if I wait it out, if I don't collect any of these batteries over here and wait for 5 seconds, I lose the game. I can quit if I want, and if I can retry. We obviously we have main menu too. So we're going over everything in this game, including UI. We're taking a look at win conditions, animations. We're coding everything from scratch. We're using the third-person template, but we're not using any of their built-in movement. We're going to create our own character, add our own functionality to this character. So it's going to be a game that you have. Hey guys, and welcome back. Now we will take a look at Unreal Engine 5 and try to create our own project. So what you have to do is open up your Epic Games launcher, and the Epic Games launcher is essentially a poster to Unreal Engine and its marketplace. So let's take a look at the marketplace over here. So the marketplace essentially has all these different high quality assets that I can use. And one thing I love about the marketplace is that it has something called the free for the month part, where it chooses 5 paid assets from the asset store from the marketplace, and it provides the users of Unreal Engine these assets for absolutely free. So that is an amazing feature, and that's why I love the Unreal Engine marketplace. It has a lot of different high quality assets, and even Epic Games, most of the content Epic Games provides is completely free, and you can use it in your game. So try to check out the marketplace and use this in your game. It's not cheating. It's actually an amazing thing that you'll know how to use other people's assets on your game, because that's how game development actually works. Let's try to see how to install Unreal Engine 5 now. If I open up my Epic Games launcher and open this UE5 part over here, it has my it says Unreal Engine 5 early access. Now Unreal Engine 5 is not complete, which is why it still says it's in early access, but I can download my early access from here, and I can also get the sample project that they showed in the Unreal Engine 5 showcase video, which is amazing. But once you're done installing Unreal Engine 5, if you go to your library, you will see your Unreal Engine 5 editor over here, and I can open it up. And over here, if you scroll all the way down, if you go to Vault, you have all of the assets that you've bought or claimed. I have all of these assets. All of these are free assets, and they're amazing. So try to check the assets out, and maybe you might like something and make a game out of it. Anyways, I can go here and hit launch, and if it takes a while, don't worry. I have my Unreal Engine 5 installed on my HDD just because of how big it is. Usually I have the engine on my HDD, and then on my SSD is where I have all of my projects saved. So you can do that. You can have the same approach, or you can do something different. It's completely up to you, but that's usually what I do. It takes a long time to open up Unreal Engine for me, essentially because I mean, one, I'm recording, and two, because of the fact that for Unreal Engine you need pretty decent specs. I have like average specs. For example, you can see I have a 6-core CPU, and memory. When it comes to memory, if you're trying to make a game using Unreal Engine, make sure you have at least 16 GB RAM. Don't try to create a game with 8 GB. It is not going to work out well for you, especially if it's going to be a high scale game. And make sure you have a good graphics card. I have 2 GB VRAM, so I can barely get through this. But if you're purchasing a new laptop or a new computer just for game development, make sure you have a good CPU, which is 6 cores at least, or more than 6 cores. it uses a lot of CPU power. So if I go to processes over here, you can see Unreal Engine is hogging up my CPU like crazy. And if I go to my performance, again, memory, make sure you have like at least 16 GB RAM, especially Unreal Engine 5. You will not be able to get through it, I swear to God. But anyways, let's go to games. And we have a lot of these templates over here. So if you want to create a really quick prototype, the best part about Unreal Engine is that you can create prototypes really, really easily. So if I want to create a first-person prototype, I can, instead of creating the movement, the projectile movement, everything from scratch, I can just use the template over here, and it will create it automatically for me. So I have my shooting part, my keyboard, uh, my joystick, all of them built in, so I don't have to create it from scratch. Now, this is very, very useful when it comes to game jams. Essentially, game jams are competitions where you are given like a day or 2 days to create a game, and for those, it's very, very useful. So you can see I have a lot of these different projects. I'm going to be using the third person, except we're going to create the animations, the game, the movement logic, everything from scratch. So that's why I'm going to use the third person. And the reason why I'm using the third person project and not a blank project is because I have a lot of Unreal Engine provides a lot of animations, and I need these animations in my game. I don't want to make my animations from scratch, which is why I'm going to use the third person project. Now, under quality preset, I'm going to change mine to scalable. I'm going to enable starter content. Starter content is essentially like a bunch of assets Unreal Engine gives for free, like textures, materials, particles, etc. Under project name, make sure this on the blueprint, not C++. There's not a C++ course. There's not a C++ course. The next the next course that I'll be releasing, that's going to be a C++ course of the same game. Anyways, I'm going to name this Battery Man and create project. This might take a while, especially if it's your first time. This might take a while. For me, not much, but when it's compiling shaders, that's when it takes a very long time. So if you have a project that has a lot of different gameplay logic and assets built into it, then it is going to take a very, very long time, especially because it has to compile these shaders. Okay, now that it's open up, you can see that we have this scene. Everyone who opens up the third person scene, this is the default scene over here. I have the floor, stairs, a lot of cubes, the character, blah blah blah. Um, let's try to go over all of these one by one. Now I have the place actors tab where I have different components or actors that I can add on to my scene. What is an actor? An actor is an object that can be placed on the world. This is an empty actor, and I can then add logic to this actor over here. Now, how this works is that everything that can be placed onto a scene is an actor. So the box trigger is essentially an actor. Look at it this way. A Tesla Model S, for example, is a car. It is an electric car, but it's still a car. It derives from a car. That's how this works over here. The empty actor is universal. Everything that can be placed over here is an actor. So this is an actor, this is an actor, but we have different types of actors. So from an actor, something called a pawn is created. A pawn is an actor that can be possessed. Possessed meaning you can add input to this pawn over here. For example, you can move the pawn like a vehicle, etc. A character is basically a type of pawn that can move around. So this is how the hierarchy works. You have an actor first. Under this actor, we have a pawn. So the pawn inherits from an actor, and the character inherits from a pawn. It basically has like a mesh, collision, etc. Let's talk about collision, shall we? Select this third person character, and in the world outliner, you can see that this third person character has been selected. And under world settings, I have my game mode override. We'll take a look at all of this later, but let's go to our details panel. Under details panel, I have my capsule component, which is basically collision. The way collision works in games is that you have a capsule. You don't have all these complex collisions like the exact shape of the character. That is not going to happen. It's very, very resource hungry. We use simple collisions in our games, and what collisions do is it makes sure it doesn't walk through the stairs over here unless you want to create a ghost. I can move up these stairs, I can jump, I'm solid. The collision basically says, okay, this object is solid. But that does not mean collision cannot be, you know, a collision cannot be cannot walk through the wall. It definitely can. You have different presets. For example, I can set my collision in such a way that I can move through stairs, but I cannot move through a floor. I can do that. I can definitely do that. All you have to do is select the capsule component, and once you select the capsule component, under in this part over here, we have different attributes essentially, like the transform, the shape, the navigation, all of that. Now the transform is universal for every single game engine. We have the location, the rotation, and the scale. The red is for the x-axis, y is for the green is for y-axis, and the blue is for the z-axis. You can also see these arrows over here. If I change this red arrow, if I hold this red arrow and like move my mouse, you can see that my x-axis is getting changed. The same for my y and my z. I can also move two axes at the same time. For example, my z, oops, okay, that's pretty weird. I can move my z and my y axis at the same time. It's really, okay, you know what, I'm going to move my x and my y just because it's simple. You can see that my values, the corresponding values also change. Um, so when you're trying to place objects, that is, you'll sort of have to understand how to change all of these values. Now I can also change the rotation. If I press E, I can change my rotation. So you can see I can go up and down. I can change, for example, okay, let's actually go back. If I change the green part over here, you can see that I'm changing my rotation with respect to my y-axis. Same goes to the blue and the red. Let's not waste time. And the scale is obviously the size of the character. I'm going to change this back to 0. I don't want a humongous character. Oh, okay, never mind. It's supposed to be 1, not 0. If it's 0, it's not going to have the x dimension at all. It's going to be a two-dimensional object. Capsule component, if I have something called mobility, and this is present for every single object. So for example, if I select my network, my player start, a player start is essentially, it defines where my player should start. It says network player start, so that's for multiplayer. So this capsule component, under capsule component, if I have something called mobility, I can basically say if my character should be static, movable, or stationary. If my character person gets some input and has to move in one of these axes or even rotate, I need to make sure that is movable over here. I have my animations. We'll be going over all of this later on. We'll be creating this from scratch. I have my mesh. I can select if I want to simulate physics or not, and that gives realistic physics. I can enable gravity or disable gravity. Actually, you know what? Try to change all of these values and try to see what it does. That's the best way to learn, to just um, explore and try to change all these values. Hopefully, you don't break the engine. I have my capsule components. So I basically have different components attached to my character, and these components have different attributes. For example, my hair has different attributes. My legs have different attributes, but as a whole, I am a person. So that is basically how this works. As a whole, there's a third-person character, and it has different components attached to it. I have my camera, etc. Now you can see that it says it's inherited over here. It means if I hover over this, it says my parent class's character. What I mean by inheriting means this is actually a programming concept, and what this means is that the parent class has a set of attributes that I inherit on my child. This third person character. This is not this inherits from the character class. So you can see the parent class. It says the character class, and the character class has the capsule component, the mesh, etc. So I don't have to, if I create a child of this third person character, a child of this character class, I have all of this built in. Think of this as think of your parents. If your parents have, let's say, brown eyes, the chances of you having blue eyes is pretty low. So you're trying to inherit the genes from your parents, and it's getting passed on to the child. That's how programming works too, and that's why it's so beautiful. Now, when it comes to the content browser, I have my blueprints. The content browser is used to navigate through your game files. Um, and that's pretty much what it's used for. And I have different folders. This has been created by Unreal Engine automatically because of what template I've chosen. So if I go to blueprints, I have my third person character. Before that, let's first familiarize ourselves with the place actors part too. If I go to, I have different tabs over here under place actors. I have my directional light, my point light over here, spotlight, all of that. So just like real life, I can drag this value into the scene, and it has automatically selected whatever object I've added. I can change all of these values. For example, I can change the light color to like, I don't know, blue, red, etc. I can change my intensity. I can either make it absolutely bright or very, very dark. So this CD stands for uh, whatever. Okay, I don't know. I suck at physics, but anyways, that's what intensity is for. My attenuation radius. That's all of these are physics light concepts. So if you really, really like physics, you'll probably be able to um, uh, recognize all of these different variables over here. Unfortunately, if you want to get really good game development, a little bit of physics, a little bit of math, it is important because programming is essentially just math and physics, but in a very very practical way. So you don't need to know math, physics, and all of that, but it does help a lot. You can understand the concepts a lot better, especially when you have to debug something or add a completely new feature. Anyways, let's not waste any more time and let's create a new level so that we can add our own characters, our own objects to the scene. If I click on my file, I can go to new level. I'm going to create a default level over here and it'll automatically ask me to save this one over here. Now, if I press Control S, I can save this on my folder. I'm going to right click over here, create a new folder called scenes, and I'm going to call this level 1. Actually, yeah, this should be called levels. I used to do this in Unity a lot. It's supposed to be levels. In Unity, it's usually called scenes. Yeah, there we go. Okay, I'm going to remove the floor and the player start that they actually, yeah, I'm going to remove the player start. We'll add all of this. I have something called atmospheric fog, which but has a lot of influence on light. But I can also add something called the exponential height fog, which adds a lot of depth to the map. Actually, try to explore over here, try to add different objects onto your scene, as I said. But we'll be creating something called a landscape over here. So I have something called the landscape tab. If I click on this, you have something. Okay, all of these lines that you see over here, this is usually called gizmos in game development. This applies for all game engines. These lines, they're basically called gizmos, and they're basically outlines of whatever object you've selected. The reason why I'm creating a landscape and just not adding a cube over here and scaling it is because it is very, very well optimized. Landscapes are optimized for huge, huge levels. And I'll actually show you why. Over here, if I go to my landscape tab, I can change a lot of different values, but all I'm going to worry about is my section size. I'm going to make this 7 into 7 quads. So you can see it's 7 over here and 7 over here, I guess. 1, 2, 3, 4. Yep, there we go. And I am going to create this. Now, the reason why I say this is very well optimized is first off, I can change the depth of this landscape, and you will see in just a second. Oh, I forgot to add a material, but no problem. We can add that later on. It might take a while, especially if it's your first time, for it to set everything up. But once you've hit create, let's just wait for a bit. Okay, you can now see this huge white cursor over here. Let's change the brush size to something small. You can see that it has automatically selected the sculpt part, and I can basically add some depth to this map. For example, I can create mountains over here, and if I want to flatten it, I can select the flatten part and then completely smoothen this out. And flatten this to do the reverse of actually no. Now this automatically selects the sculpt part here. I can basically create mountains, etc. Smoothen, well, it's pretty self-explanatory. It smoothens it out, and you can see that the shadows start disappearing, and it's kind of the opposite of the sculpt mode. Flatten makes the land as flat as possible. So if I want to like add a river over here, I don't know if you guys are aware, but Unreal Engine has this amazing water system. So if I want to add like a pond, not a river, that doesn't make sense. If I want to add a pond over here, I can easily do that. But the reason why I'm using landscape is because, let me show you something. Let's actually go all the way. Let's sculpt this part over here, and let me change the tool strength to like zero point 0.4 so it's faster. You can see that it does not render the graphics over here because it does not have to. Like, I mean, why would I want to render all of my graphics, the depth, the complete height of this graphics over here when the player is not going to see it, right? It's all about optimization. Now, this is also one of the reasons why you've seen in many games, if you have some collision issues, for example, if I don't have collision over here and the player just sort of falls through the map, if you keep falling, you can actually notice that you won't be able to see the top of the level. That is because of the optimization part of this landscape or whatever they're using. It applies to a lot of different game engines. It was very, very common in Grand Theft Auto San Andreas. And also Cyberpunk. But anyways, that's pretty much why I'm using landscapes over here, and also because I can use the sculpt feature over here. Let me just. I'm going to add some depth. I'm going to make this look like an actual ground so that it's not completely flat. I find that really, really boring. I hate when objects are completely flat. So I'm just sort of going to do that. And let's so you can see that it's editing something called the height map. The height map essentially adds tells the map where how high the level is. For example, at this coordinate, my I have like a mountain of some sort, and over here I don't. So that's pretty much what it's doing over here. Now, if I want to go back to my select mode, I can just click on my select mode over here, and that is pretty much it. So if I select my landscape, I can change a lot of these values. What I'm going to do is I'm actually going to create this again because I didn't show you how to add a material. So when you go to your landscape mode, you can see this material part over here. Try to select the ground material and let's create it again, and it's going to be 7 into 7. So that's how you add material. And again, I'm going to add some depth over here. Just rub this around and make sure you have you click your mouse. Don't just try to run this around. Okay, that is that. Awesome. Now we've created a landscape, and also another good part about this landscape mode is that it scales the texture automatically for you, so that it's not just one part of the texture. It sort of scales it automatically. So I really really love that about the landscape mode. Um, so try to add some lights onto your landscape. Try to experiment on your own. Try to change the light, the color of the light or the intensity, whatever you want. And let's try to tinker around the exponential height fog. If I go all the way to the top, I can change the fog density to make this really, really foggy. I want to give this a sort of Martian-like look. So I'm sort of gonna make that red in color, and yeah, that looks really good. Okay, now let's get into the coding part. Well, it's not exactly coding. It's something called blueprinting, and that's the visual scripting language of Unreal Engine, and I absolutely love it. If you go to the blueprints folder, you can see the third person character. Let's just double click. Now remember, this does not mean you can completely get away with just blueprints. You will need C++ if you're making a full-fledged game and releasing it. Why? Because blueprints are mostly meant for prototyping and small features. If you're trying to make a multiplayer game, for example, you can't get away with blueprints because blueprints is not exactly the fastest programming language. It is also a programming language, but it's not fast. C++ is a lot faster, which is why we're going to create the exact same game in C++ later on, but that is a different course. This is only going to be blueprints, as I explained before. This might seem a little confusing for you, but actually these are two different windows. And if I go to my viewport over here, I can see my third person character in action. And I can see my collide. I can see all of my components all together, like the camera, the arrow component, all of that. Let's try to take a look at all of these one by one. We've already taken a look at the capsule component. Let's take a look at the arrow component. This basically points towards the it points to the front of, I mean, to the forward vector, or it points forward all the time. Let's take a look at the mesh. The mesh. Okay, so now we have two different types of mesh in Unreal Engine. One is the static mesh and one is the skeletal mesh. The static mesh is used for stuff like, let's say, a cube, for example. If I drag this cube over here, you can see I have a static mesh. That's mostly because this cube is probably not going to move and it does not have any extra animations. Like, I mean, what am I going to animate out of a cube? Maybe I can make this fall, etc., but I don't need a skeleton. I don't need something called a skeleton for it. But I have something called the skeletal mesh, and this is the complex counterpart for the static mesh. A skeletal mesh is essentially a mesh with something called a skeleton. Now, how animations are created is you have something called a skeleton and it's assigned to a particular mesh. And you have the skeleton is of a bone and it's almost just like the human the human skeleton over here. Now, how animations are created is you take a specific bone and you sort of change the values. For example, if I rotate this bone over here, I can sort of create an animation. I mean, this probably looks like I'm slapping someone, but that's pretty much how animations are created. I manipulate the transform values of these bones over here, like okay, not the middle finger, maybe the index finger, and yeah, there we go. I can do that. So that's pretty much what animations, how animations are created. Now you can create animations in Unreal Engine, but I'd suggest you to, if you want to learn how to make animations, there are a lot of Blender courses online by Game Dev TV or anyways, there are a lot of there's a lot of Blender courses online. Please try to take a look at it. It's amazing. But this is the skeleton that Unreal provides us with. I have something called the camera boom. Now, if I hover over it, this is the spring arm component. And the spring arm component essentially, the reason why we're not adding the camera directly is because if I have a wall behind, and if my character is moving behind, if my character is moving back like that, okay, I haven't moved the capsule. I'll actually move the mesh. If I keep moving back and the camera moves with it, the camera might clip through the wall. I don't want that. I want my camera to sort of move up as the wall, as I'm getting closer to the wall, which is what a spring arm is used for. It makes sure that the camera doesn't move through the wall. Now the follow camera is, well, the camera itself, and if you want to change the position, I'd rather change the values of the target offset over here. So if I change this like maybe 30, I mean 300, you can see it moves with respect to the y-axis. So I'd do it that way anytime. So I'm going to, if I want this higher, I can change the socket offset and then press E, change the rotation like that. So that's the way to go when it comes to making a camera system. And I have the character movement. This is a built-in component created by Epic Games, and this basically has different values that you can manipulate. For example, the movement values. Let's actually try to change these. If I search for my walk speed over here, let's actually search for the maximum walk speed. If I change this to, like, let's say 350 over here, and if you want your changes to get saved, you have to make sure you hit on the compile button. And if I press Alt P, you can see that I am walking slower than usual. So I can basically manipulate all of these values, and this is, again, you can see that it's inherited. So this belongs to the character class, and this character class has all of these inherited, so I cannot delete any of these. Let's change this back to 600. But anyways, it doesn't matter because we're creating our own character. The event graph is where you create your logic. So these are all called nodes, and you can basically drag and drop these nodes over here to create your flow of the code. Don't worry if this is very confusing. We'll be creating all of this from scratch. Okay, and yeah, that's pretty much it for the event graph. And if I go to my construction script, this occurs even before the game starts. So if I want to add some functionality to my game engine, I can do that in the construction script. In my event graph, I have my variables part. Let's take a look at the graphs. I can create different graphs. For example, I can create a new graph just for movement if I want to keep this very, very tidy. But we're not going to do that. We have a very simple script, so that's fine. And we have something called variables. A variable is, okay, I'm going to remove that. A variable is basically something that can contain a value. Variables can be of different types: floats, integers, integer 64 byte, double. Let's take a look at all of these. A boolean holds a true or false value. Byte is an 8-bit number. Integer is a number bigger than the byte. Integer 64 is a 64-bit number. Float is a decimal number, so that's like 3.14 or 10.6 or 6.9. And double is a big 64-bit floating point number, so it's like 6.9999999, etc. I can keep going on until 64 bits of memory. A name is a piece of text. A string is basically any single value that's in quotes. For example, it could be my name or the word hello or the sentence hello world. That could be a string. A text is, well, this is a different type of a string used for UI, etc. Name is mostly used for scene names, level names, all of that. A vector in physics is basically a value that has a magnitude and direction. So I can say x is moving at 10 to 10 meters square per second in the x direction. So that's a vector, and a vector consists of the x, y, and the z values. Rotator is for rotation, and it also has the x, y, and z values. A transform we've already seen. It's the rotation, location, and the scale. It is universal for every single game engine. So yeah, that is the basics for the blueprints. Now let's go ahead and create our own character. So I'm going to create a new folder first, and I'm going to call this custom blueprints because I want to differentiate between the ones that Epic Games has created and the ones that I've created. And it's very important to be organized. Now, okay, trust me on this. Every single game developer will ask you to be organized, and they themselves will not be organized. This happens all the time. But it is best practice since you're just starting to learn. Try to keep your project as organized as possible. Now over here, I have my desktop icons hidden, but if I show it to you, you'll probably see how organized I am. Make sure you don't make that mistake. Try to organize your folders as much as possible. Under custom blueprints, I'm going to create a blueprint class, and this is going to inherit from my character. So I'm going to have every single functionality that this character provides. For example, I can walk around, I can add input, but the code, I have the ability to do that, but I need to make sure I tell my character to move. That's like you have the intelligence to make a game, but you need to learn how to make a game. That's pretty much what we're doing over here. So I have a character, I can select that, and the naming convention is usually BP underscore the name. So I'm going to call this battery man. um, and if I open it up, I don't have the mesh anything. So if I go to my third person character and try to compare it, all of these inherited parts, I have them on my BP underscore battery man. I don't have the mesh because the mesh isn't, I mean, I don't have the camera and the spring arm component because that is not inherited. So let's actually copy these and add them to our character over here. Oh, actually, seems like, yeah, we can copy them. Copy, and we can paste them over here. So I already have my camera added, or you can just say add camera and then add spring arm component, etc. Okay, I have my camera, compile and save, and let's assign our mesh. So if I go to my mesh, I can go to my skeletal mesh. I have only two of these. I have the female and the male. I'm going to use the male mannequin. We're going to bring this all the way to the bottom by 80 units. Actually, let's do 90. Um, Actually, no, I think 80 would be fine over here. And press E, and let's move that by 90 degrees. And again, that's the Z axis. Compile and save. Let's try to run the game. You may notice that I still have my third person character, and if you're still confused as to what character I'm using, you can eject from this character. What does that mean? Just press F8 in your keyboard, and then the game is still running, but I can basically debug the scene over here. Now, if you select your third person character, you can see that I'm still using my third person character. My player hasn't spawned. And that sparks a question. How does the game engine know, without adding any functionality, how does this know that I want my third person character to spawn? That doesn't even make sense, right? The reason is because I have something called game modes. If you go to edit, project settings, let's take a look at the maps and modes part. Over here I have something called the game mode. The game mode basically sets default values for every single scene. So I can say no matter what scene I create, I always want my third person character to spawn. And in that scene I can say, for example, if it's the main menu, I can have an override game mode which says, okay, for the main menu, don't spawn the character because that's weird. So I'm going to just have my UI, etc. I don't want my character to spawn. So that's how Unreal Engine works. So over here on my default game mode, I'm going to change this value to BP underscore batteryman. And now if I press Alt P, I can see my character over here. But obviously I don't have any functionality. The reason is because I have the ability to take input, but I haven't done anything with that input yet. So that's what we're going to add over here. So if I go to my event graph, let's actually take a look at all of these events over here, which we haven't seen before. I'm going to remove these. Okay, now the event play, let's actually see what this does. The event play event, it executes whatever code that's attached to it in the beginning of the game. So only once. It's going to get executed once, and that's when you begin playing the game. Event tick, it gets executed every single second. And let's actually take a look at an example. If I drag, so this over here is called the exec node, and I can release it to place a new node. And I can just say print string over here. The way this works is when I call begin play, when begin play is called automatically, and that time it's going to print out this string over here. And I'm just going to say this is begin play, compile, and let's play the game. Alt P, and you can see that says this is begin play. Now I'm going to add a player start. The player start essentially defines where my player stood at, where my player should start the game. So now I don't fall off the map. So now it says that this is begin play. I'm going to now press Alt and click this button over here, and then move this to the bottom, and then drag the event tick node over here. Now this can be anywhere, but I just asked you to bring it to the bottom because I want this to be neat. So compile and save, Alt P, and now you can see that it's printed every single frame. Now remember, this might be different for every single computer. If my game runs at 60 frames per second, this function will be called 60 frames per second. But in a different person's computer, let's say you have an RTX 3080 and your game runs at like 160 frames per second or 120 frames per second, then this function will be called at 120 frames per second. That is how the tick function works. For Unity users, this is like the start and the update functions, very, very similar. So we're actually not going to use any of these because what we're going to do is we're going to say if I press my W key or my S or my A or my D, move the character, and if I press, let's say, my mouse button, print something out. That's what we're going to say over here. So if I minimize this window, go to Edit, Project Settings, I have my input part over here. I have two types of bindings over here. One is the action binding, action mapping, and one is the axis mapping. Action mappings are pretty self-explanatory. I just have my spacebar over here. I'm actually not going to bother adding. Our game does not have any jumping mechanics over here, so we're not going to add any jump, but I'll show you how to make your player jump. So this basically says if I go back to my blueprint, right click and jump event, you can see under input action events I have this jump, and this button, when I press my jump button, do something, if I release my jump button, do something. And what's the jump button? The jump button is my space bar, and for my gamepad it's my face button, bottom button. Anyways, I'm going to remove all of these. Unreal Engine, obviously, look, it seems like it supports a lot of different consoles, which is awesome. And my axis mappings, this gets a little confusing. I'm going to remove everything I'm not going to use again because it gets very confusing for new developers. So I'm going to remove all of these. Now, if I press W, I want to return a value of 1, which is basically going forward. If I press S, I want to return a value of -1. And if I press A, I want to return a value of -1. If I press D, I want to return the value +1. Why? Because take a look at the axis. If you go forward, it's usually positive. If I go backward, it's negative. So to my movement input, I'm basically going to say add 1 to, as long as I'm pressing my W button, add 1 to my movement input. And if I press A, it's going to add a value of, let's say, -1 at that particular direction. Um, so why is A -1? Well, take a look at the x-axis. If you look at the x-axis, the left part is -1, the right part is +1. So that's basically how the coordinate system works over here. Turn rate. What we're going to do over here is we're actually going to delete our turn rate and and our lookup rate over here. And what we're going to do is, instead of this, we're going to call this look right, and then we'll call this look up. Look up is your mouse Y direction. It returns a value ranging from -1, and for look right, if I move my mouse in my X direction, it returns a value ranging from +1. Let's actually see what that does. Now, in my input action, if I press this, I want to print I am jumping. So I can just compile, save that, go back. I can remove this now, and Alt P. If I press space, it says I am jumping. And if I release this, if I go to my release part over here, it's only going to print this out when I release my button. Okay, now let's try to bind all of let's try to add some functionality. If I right click and then search for mouse X, make sure you get the events and not the mouse values. So I'm going to get mouse X and mouse Y, the events. So let's actually see what I mean by when I say it returns a value ranging from -1. So what I can do is from this node, I can print a string, and this is a float. The green part is for float. What this is doing is it's giving an output of, or returning a value of a float, which is the axis value. And if I drag this in, it's going to convert a float to a string. If I compile and save, go back, Alt P. If I move my mouse left and right, actually that was mouse X, yes, so that's going to be left and right. You can see my values are ranging from 1 to -1. I mean, it starts from 1. If I go right, it's going to be positive. It's going to go, if I go left, it's going to be negative. It just keeps adding that value over here. And the same goes, you can try this out for mouse Y. I'm not gonna waste time trying to do the same thing for mouse Y. I'm just going to do the same thing. Okay, so let's actually try to add our mouse movement over here. If I go to my spring arm, I have to make sure it always says use pawn control rotation. Why? That's because when I change, what I'm going to do is I'm going to change the control rotation of the pawn, and that's how I'm going to change the rotation of the spring arm, which changes the rotation of the camera. Why? Because the camera is the child of a spring arm. What that means is that if I move my spring arm, the camera is going to change with it. Just like how a kid follows his or her mom all the time. That's basically how the spring arm, I mean, the parenting part works over here. Same way, the arrow is a child of the capsule component, the mesh is the child of the capsule component, etc. Which means as I move my capsule component, the mesh moves with it. Okay, so we're going to change something called the yaw and the pitch. The pitch is the y-axis, the yaw is the z-axis. So with this axis value, we're basically going to add that value to the y or the z-axis. Let's see how to do that. Let's drag a node and we're going to search for it. If it's the x-axis, we're going to add the yaw to it. Why? Because the x-axis, if I'm going to rotate with respect to my x-axis over here, that means I'll be rotating it, sideways. I don't want that, right? So I'm basically going to rotate it with respect to the z-axis, which is basically left and right. So I can plug in this value over here, copy. I mean, I'm not going to copy that. I'm just going to I'm doing the same thing, but for the pitch over here. So add controller pitch input. Now, keep in mind, if I have this disabled, so Alt and click that, if I don't have an exec node connected, it means this function will not get executed. What is a function? A function is a chunk of code which may or may not take an input, and it provides an output based on that by processing it. So you have an input, it processes that input, calculates, that does something, and then provides an output. The output here being the camera getting the camera rotating on the scene. So if I go back, Alt P, you can now see that I have proper camera movement over here. Now, if your axis is inverted, like for example, if I go up, I want to go down, and if I move down, I want to go up. If I want to do that, all I have to do is go to my project settings again, go to my input part, and I can just change my mouse Y to +1. And if I Alt P now, if I move up, I mean it does the opposite essentially. Okay, let's open up the blueprints again. We did this for our mouse, but we need to add movement obviously to it. So let's do that. Now let's get our events. So our move forward event was basically binded to the keys W and A. I mean W and S. So let's search for the axis event over here, and let's do the same for move right, the axis event. So I have the axis value over here. For move forward, I'm going to add this axis value to something called the forward vector of the character. The forward vector is basically a vector that defines the forward direction. And here we're going to add this to the right vector. The right vector is essentially the vector that defines the right direction. So if I right click and add movement input, if I search for this, I need the world direction over here. The world direction is basically going to be get actor. Uh, let's actually get the rotation over here. So if I drag this over here, get rotation, get location, get forward vector. So this is going to get the direction is going to be the forward vector because we're either going to move forward or back, and this takes an input as a rotation. Now this is a variable. The forward vector is a variable, and it's if I mean this is a function. The forward vector itself is a variable. This get forward vector is a function, and this does not have an exec node, which means it's a pure function. It returns a vector, and I can add that to the world direction. The scale value is going to be the intensity, which basically whether if I press W, it's going to return a positive value. If I press S, it's going to return a negative value. And in rot, it's basically the rotation. I'm going to get actor rotation over here, and that's basically what it's doing. It's basically doing some complex math and then saying, okay, I know what the forward vector is, so move depending on that direction. Now the same thing over here, add movement input, but this is going to be for the right vector. So get right vector, and we're again going to use the actor's rotation over here. So that's that for our movement, and that's pretty much it. We're done with movement. So if I Alt P now, I can move left, right, forward, back, etc., and it works perfectly fine. But my character is still in this V pose or this T pose. The reason is because I don't have any animations assigned. Before that, let's actually see how to make this neat. Now, okay, the length of this node or the length of this line does not matter. It's not going to affect the speed at all. Just adding that. I was dumb enough to believe that the speed was affected because of it. Don't be like me. It's not. But always make sure it's neat. Make sure you can see which line, which axis, I mean, which variable is getting connected to what, etc. That is very important. So compile and save. Now let's start to document our code over here. If I select all of this and press C, I can add something called a comment. This does nothing, but it's just for us, for our understanding. So I'm just going to say add movement input over here. And over here, I'm just going to say add mouse input over here. Now, we're not gonna make our character jump, but in case you want to add that functionality, I'll show you how to do that. Um, if I right click and search for the jump event, so remember we have an action event called jump. When I press this, I want to start. I want to just jump, and jump is a built-in function of this character class. So the character automatically starts jumping, and over here I can say stop jumping because I don't want to keep going higher and higher and higher. So Alt P, I have my jumping over here too. Awesome. But I'm not going to bother adding this because I don't want this in my game. But yes, that is that for movement. Now that we've added movement, the next part is to add animations. A lot of people don't like animations. I personally don't like adding animations, but unfortunately, it is a part of game development. So let's try to learn how to do that. For animations, I have a different blueprint that I can add. I'm going to go my content part and new folder. I'm going to call this animations. And let's create something called an animation blueprint. Now, the reason why we're using an animation blueprint and not the normal blueprint is because the animation blueprint is optimized specially for animations, and it has a lot of different functions built in. Now, to create an animation blueprint, I have to attach this or assign a skeleton to it. We've already seen what a skeleton is. So different animations are made for different skeletons. So make sure we select the UE4 mannequin, which is the built-in skeleton. Press OK. The naming convention is ABP. Oops. Again, right-click, rename. ABP underscore. I'm just going to name this battery man over here. Double-click. And now I have my output pose. I have two different graphs over here. I have something called the anim graph, which basically decides the output pose. And in the event graph, I can, let's say, get the speed of the character and then change my animations based on that. That's what these two graphs do. The event graph is for all the functionality, like getting the variables, adding values to the variables, etc. The anim graph is to decide the output pose. If I drag a node from here and search for the run animation, play third person run and compile, now this over here takes an input. If your variable is on the left side, it means it's taking an input. If it's on the right side, it means your node is giving an output. So the third person is going to get the animation, use the animation pose as an output, and that output is sent as an input to this output pose over here. Compile and save. I have to go to Batteryman and assign my animation blueprint. So I can either select my animation blueprint and then hit this arrow over here, or I can just search for ABP underscore Batteryman. Now compile and save. If I run this now, you can see that my animation is getting played continuously. I don't want that. I want my idle animations, all of that. I want a different animation for strafing. It just looks really weird. So we're going to create something called a blend space for that. Let's take a look at what blend space is. So go to animation and search for blend space. And again, you have to assign a skeleton. So there's going to be BS underscore battery man. Um, Okay, now let's open this up And this might look a little confusing, but essentially the blend space has the x-axis and the y-axis, and depending on the values of this, a certain animation will be played. For example, let's take a look at the vertical and the horizontal. The vertical, I think the vertical is this one over here. Yeah, that's the speed. So that's your vertical axis. We're going to name this the speed and name the bottom one, the horizontal axis, the direction. So based on my direction and my speed, I can play a particular animation. So my minimum speed over here is going to be 0. My maximum axis value over here, my maximum speed is 600 as we set in our movement component. My minimum axis value here is going to be 180. My maximum is going to be positive 180. So why positive 180 and negative 180? 180 is usually forward. Negative 180 is the complete opposite direction. So that's what we're doing over here. Okay, so basically what I'm saying is, actually let's do this with an example. Search under this asset browser, search for your idle animation and drag and drop this at the bottom. What I'm saying here is, if my speed is 0, regardless of my direction, make sure you play the idle animation. I'm pretty sure you can now understand what this is doing. So if my speed is 0, then I'm going to play my idle animation. Now you may understand where to put your run animation. It's going to be all the way at the top. Now, if you hold shift and actually sort of move around, you can preview the animation. So if my direction is at 0, which is forward, and my speed is at 600, then I'm going to play that animation, and it slowly adds the value. So my animation slows down as I go down. And my preview value, if my speed is at 0, regardless of my direction, I'm still going to stay idle. So that's what it does. Now, if my direction is at 90, I want to make sure I move left. So let's search for run, and actually let's take a look at all of our animations over here. Um, okay, so what usually happens is we have different animations for when the character turns left and when the character turns right, but the animations that come built in, we unfortunately don't have those animations. So what we're going to do is we're just going to add run over here, and remember, when my direction is at usually you'll have also a backward run animation. So when the direction is at minus 180 and 180, you usually want you want to move backwards. So you'll have a different animation for that, and you will add that respectively. So let's just add this animation. I really don't want to do this, but uh, in our C++ course, I'll make sure we get animations for moving right, moving left. Actually, let's try deleting all the other values. Let's just have one for moving forward. If I save this and Alt P, okay, obviously I need to assign this blend space in the animation blueprint because we still haven't assigned it yet. So if I go to my animation blueprint, I can drag a node and search for blend space. So now I can see my blend space bs underscore battery man, and this takes in two inputs. One is going to be the direction, one is going to be the speed, and based on that, it will choose an animation, which is what we said. So from here, I'm going to drag a node and promote this to a variable. So it automatically creates a variable called direction, and it's a float. And I'm going to promote this to a variable, and it's going to be speed. Compile. Go to my event graph. Now in my event graph, I can get the speed and the direction. So let's see how to do that. Now from try get pawn owner, what this does is it tries to get the owner of this animation blueprint. So I can now cast this to my BP battery man. Why am I doing this? Well, that's mainly because I have my pawn. The pawn is the class, but I have to convert my class to my battery man. The way this works is if I go to my BP underscore battery man and add a variable, I'm just going to call this test variable. If I want to get hold of this variable, I can't get this from pawn. I can't just say get test variable. It does not exist. But if I convert this to a battery man And then as battery man, if I try get test variable, now I can get hold of the variable. So we're trying to just localize the spawn to my BP underscore battery man. So from here, we're going to actually, first what we're going to do is we're going to check to see if we got our pawn owner or not. And that is done using the isValid node. So if I get my pawn owner, if I'm not able to get my pawn owner, I can just print a string saying I pawn owner not valid. Now the reason why we're doing this is because if we're trying to get a few variables from the pawn owner, we need to make sure we have that pawn owner. If not, your game is going to crash. So this is the safer way of doing it. If it is valid, what we're going to do is we're going to cast to BP underscore battery man. And this has an exec node, so obviously this goes to isValid. As battery man, what we're going to do is we're going to get a variable called get velocity. So the velocity is obviously the speed, but remember, velocity has direction and magnitude. So from get velocity, we're going to get we're going to calculate. We're actually going to get the we're going to get the vector length. The return value is going to be your speed. So we already promoted this to a variable. So we're going to set this variable here. So drag this variable onto your event graph and press Alt, and then you can just drag the return value onto speed, which means now the value of the speed is going to be the velocity, the vector of velocity from battery man. We need to obviously set the direction too. We're not done yet. So from here, we're going to get actor rotation. And from the rotation, we are going to calculate direction. So obviously for the direction, you need to calculate the velocity. So from the velocity, you get something called the direction too. That's how vectors work. And again, I'm going to do the same to direction, and I can set the value. After setting speed, I'm going to set the direction. So the control flow is basically update animation. There's basically going to happen every single frame. From here, it's going to go to isValid. It's going to check if the pawn owner is valid. If it is, cast to BP underscore battery man. So convert pawn to battery man. From here, get the velocity, get actor rotation, calculate the vector length, calculate the direction, set the speed, and then set the direction. We can, yeah, actually, we're going to keep this over here. Now we have the values for speed and direction. All you have to do is go to your anim graph, and you can see that it has already set the direction and the speed. So now compile and save, go back, and if you press Alt P, I now have my animations. Obviously, it does look a little weird that if I go left and right, I don't have proper animations, but that's actually going to be, actually try to do this on your own. Search for your left and right animations. Go to this blend space. When your direction is at -180 and 180, you want to make sure the character goes backwards. And for your left and right animations, here you're going to place your right animation, here you're going to press your left animation and check if it works. And if it does, then you've understood how blend spaces work, but we're going to move on. The game, as you've seen in the beginning, the way the game works is you have a lot of different batteries all around the map, and the health of the player keeps decreasing, and you have to make sure you collect all of these batteries, and if you do, then you go to the next level or you win the game. So let's see how to do that. This where we'll be learning about UI, etc. So there's going to be the second part of the course. If I go to my blueprints, my third person, actually not my third person character, obviously it has to be my AVP underscore battery man. My BP underscore battery man over here. We're going to create a new variable called health. Let's remove this and let's create a health variable. Over here, I'm going to search for, I'm going to make this a float and compile. The default value, I don't know what's going on with me. The default value is going to be 100 over here. compile and save. Now, what we're going to do is we're going to get our event tick. And every 5 seconds, we are going to reduce the health. How do I do that? Drag a node and then add a delay node over here. What this does is it's basically going to wait for X amount. We're going to wait every 5 seconds and get this value. So if you drag this value onto the screen and then hit Control and then place it, you'll be able to get whatever value your health is. And we're going to subtract. So if I just, as you can see, if I search for minus, I can subtract a value, and I'm going to subtract a value of mine of 5 maybe. So once I've subtracted the value, so let's say my health is 100. If I subtract it, the output is going to be 95, and I have to set health over here. Again, set whatever value I've returned, and then once I'm done, I can just do that. Now, basically, every 5 seconds, I'm going to reduce my health. Let's print my health out every time. Actually, for simplicity, I mean, to just make sure it's faster, I'm going to make it every 2 seconds and drag and drop health again, convert it into a string and plug it into my print string. Compile and save, Alt P. Now you can see it's 100, after 2 seconds, 95, and then it's 90, 85, etc. So it keeps going down. What I'm going to do is I am going to add some UI. I'm going to add a health bar so that this is connected to that. I'm going to reduce my health every 2 seconds, but I'm going to reduce my health by 10. Compile and save. Now, I have to do something called binding. I'm going to bind this health to my UI. So let's take a look at how to create UI. Under blueprints, I'm going to create a new folder and call this UI. And under UI, you can go to FX, actually not FX. This is under user interface, and I'm going to create a widget blueprint. The naming conventions WBP underscore whatever name. I'm going to call this player UI. So in this, we have something called the designer. And in the designer, this is what the UI is going to look like. You can design, I mean, you can basically place all of these objects and you can make it look like a proper UI. We're going to add something called a progress bar over here. Let's actually scale this let me make this 500. And I'm going to do something called anchoring. What this means is as I resize my screen, so for example, if I minimize my screen, I want this to still stay at the top left corner, and if I make it full screen, it should move along with the screen. That's what anchoring means. So I'm going to make sure that it's over there. And if I scroll all the way down under style, I have something called the fill image. If I if I if I drop this down, I have something called the tint. The fill image is going to be the actual health over here. So I'm going to make sure my battery is going to be of green. That actually reminds me I have to change this to battery, not health. Okay, and make sure you save that here and compile. And over here, our background image, let's just make this, actually let's make that black, that's fine. And we have something called the percent. Now the percent ranges from 0 to 1. If it's 1, it's going to be completely filled. If it's 0, it's going to be empty. Let's make the default full, and we're going to do something called binding it. So you see this bind button, and you can select create binding. And what we're going to do is we're going to get the health, and we're going to set that health to this percentage. We're going to convert the health into percentage, and then we're going to set it over here. So the return value is going to be the percentage that's displayed. So now we can say get player character, and that's going to return whatever character I've possessed. We're going to obviously convert this to my battery man. So once we've done that, as battery man, we can just get our health, get battery, and then we can set that over here. But remember, we have to convert this into percentage because this percent is going to be between 0 and 1. So what we're going to do is we're going to divide this by 100. Remember, by definition, percent means per cent is 100. So we're going to divide this by 100 and then return it over here. Compile and save. Now we have to add this UI onto the screen. To do that, let's have our begin play. All of our UI will be instantiated in begin play. Over here, we're going to create a widget. So we're going to create an object of this player UI. So I need to select which class. That's going to be my WP player UI. And return value, I'm going to add this to viewport. So it's basically going to add this player UI onto the viewport, and whatever function I'm binding, it's going to make sure it executes all of that code. So now if I play, you can see that my percent bar is slowly decreasing, which is amazing. And it has some amazing decal too, so it has some animated graphics, so that's very cool. That's why I love Unreal Engine. It does everything for you. And we can now remove this print string. Now again, we have to make sure it only reduces the value until it goes to 0. And once it goes to 0, I want to kill my player. So to do that, first off, we're going to decrease the value only if my battery is more than 0. So if I drag control, we now can search for the greater than symbol. And if it's greater than 0, only then execute this. But how do we do that? How do we add conditions? We do that by something called a branch. So you can see that's red color over here. So if it's more than 0, it's going to return true. If it's less than 0, it's going to return false. So from here, I can create something called a branch. And I can now add this to this branch. Now, if my health is more than 0, then I'm going to execute this. So I'm going to move that to the top. If my health is less than 0, then I'm going to say my player is dead. So that time I'm going to add a retry screen, etc. And I'm going to make sure I do not possess this character anymore, but we will see that later on. But let's create a variable now. Let's say B is player dead. That's the naming convention for Boolean values. You make sure it's B is player dead or whatever. And we're going to make sure this is Boolean. Compile. And the default value is going to be false. And if I hold Alt and drag this onto the scene, we can set this to be true over here. Awesome. Now, if player is dead, then obviously I've lost. So I'll pull out my lose screen menu, and I can either retry the game or I can play the game again. So that is the basic functionality that we're going to use over here. Once the player is dead, what we're going to do is we have this function called detach from controller pending destroy. What this does is it makes sure your controls don't affect the player once you have detached from once you're dead. So if I wait and wait for this, actually let's make that faster. I have no patience. I'm going to make that 20 so that as soon as I spawn in like 4 seconds, I'll end up dying. So that's there. And now you can see that you can try controlling, but you will notice that your controls don't work. And that's because we have detached from this controller. And we need the animation to stop playing so we can also have another. So we can either stop our animation like this, but this might not work. Let's try that out. Uh, Let me make that 20 because I don't want to wait 4 seconds. Compile and save. Alt P. Now the animations are still playing. So we have to take care of this through the anim montage, the animation blueprint. We have this variable here is player dead. So we're going to get this variable from our BP battery man. And if it's true, we're going to stop animations. Let's see how to do that. We'll be learning about a new thing called the blend by bool. Yeah, the blend space by bool. Okay, over here in this anim graph, we've seen before that we have something called a branch. So if the condition is true, do this, condition is false, do that. Instead, what we'll do is we'll say, we'll just search for bool and says blends poses by bool. Blend poses by bool. Okay, anyways, if so we can pass in a bool value over here, and if it's true, it will do this. If it's false, it'll do something else. Now, if a player is not dead, we want this blend space. If the player is dead, then we can just maybe, I don't know, we can play the idle animation over here. And how do we get this value? Same way, we have BP battery man. We can also say get B is player dead, and we can promote this to a variable. So promote to variable and bring this all the way to the top and compile. Now I think you can understand the rest. We can just drag and drop this over here, and now it's going to make sure if the player is dead, then it's just going to play the idle animation and not do anything because we don't have fuel to run. There we go, that works perfectly fine. And after this, we have to make sure we display our player Lewis screen. Now, try to do this on your own. It might be a little difficult, but just give it a shot. If you can't, no problems. We're going to do it anyways. We're going to create a new user interface. We're actually going to create two of them. One is for player win, one is for player lose. So we WBP underscore actually, we don't need a blueprint, a widget blueprint for win because we're automatically just going to go to the next level. Or we're just going to, yeah, we're just going to go to the next level. And here we can just name this the WBP lose screen. In the designer part, I'm going to add an image first. Let's scale this completely so it fits this panel. And make sure we have this properly aligned. Okay, anyways, even if it's oversized, no problems. We're going to anchor this to be full screen. There we go. So it's going to make sure it's always full screen. And I'm going to change the opacity to, I'm going to change the color to black and the alpha to like, yeah, that looks fine. We're going to have two buttons now. The first button is basically going to be, one sec. Give me a second right here. Okay, the first button, what it's going to do is, well, there's going to be the retry part. So retry game. And we need to add some text to it. The same button, I can duplicate it. And we're going to add this over here. I know it's not exactly aligned, but that's fine. This is going to be quit game if you want to quit. Color and opacity seems just fine for me. Yeah, that seems just fine. No problems. Okay, now let's see how to add text to this. All you have to do is search for text and drag and drop it. It's going to automatically pair it, make this a child. And under the text block over here, we're going to say retry game. Or actually, usually it just says retry. And under font, I'm going to change the size to maybe 34. Yeah, that seems fine. And for quit game, again, another text block. We're going to make it 34 too. And we can just say quit game. Make sure I'm going to name this text block to quit text. And this one is going to be retry. And we're going to have a huge block of text over here. And this one, we're going to name it, we're just going to say you lose. That's pretty much it. Let me make that 80. Actually, let me make it 100. And on the text block, I'm just going to say you lose. Okay, awesome. In my graph, I have to make sure I add functionality to these buttons. So if you scroll all the way to the bottom after you've selected the button, we have on clicked and on pressed. We're going to use the on pressed because it works better. For example, if you press enter by mistake, it might just end up retrying the game. We don't want that. We have to make sure we click on the button. So that's why we use on pressed. Do the same for retry game too. For quit game, not on click, on pressed over here. And for retry, we're going to load the level. We're going to load the exact same level. So that level is going to be get level, get current level name. Because if it's a different level, if it's level 2, then it has to make sure it opens up that level. So get current name ensures it gets the proper level, the level that you're running right now. And we're going to open that level. So it's basically going to open the same level again with all the default settings. For quit game, it's literally just one node, quit game. That is it. Compile and save. Now if I minimize my screen, Alt P, again, we have to make sure we add it to viewport. So if I go to my blueprints, if my player is dead, detach from controller pending destroy, that's fine. And whatever we did here, we're doing the exact same thing over here. But the problem is, remember, this is on tick. And when we put this on tick, it means it's going to create the player widget every single frame and add it to viewport every single frame, which means your game might end up crashing. So we're going to add a node that says do once. This means that it's going to, whatever that comes after, it's going to do this only once. We're going to make sure we create the loose screen widget, and then we're going to add it to viewport. Now, if you compile and save it, let's run the game. And now it says you lose. But the problem is we cannot use our mouse. We can only, we have to press Windows, etc. So if you want to show the mouse cursor, get your player controller, anything related to controls that's present in the player controller. And over here, search for cursor. Let's see what we have over here. We have get show mouse cursor, set show mouse cursor. So we can set this value. This value is present in the player controller. We can set this to true. Now if I compile and save this and minimize, and we're running around, and now I can see my cursor. If I press retry, it loads the same level again, and I'm losing and blah blah blah. So it basically restarts the level. Okay, awesome. We've done all of that. Now let's see how to convert these into functions. Functions are basically blocks of code made into one chunk of an object, which you can call later on. For example, if I right click on all of this, collapse to a function, okay, collapsing to function fail. Let's see why is that. Oh, okay, delay cannot be. Okay, okay, let's just create a test function over here. Test function. So this function can have a lot of different functionality. For example, imagine I have 1,000 nodes in this graph over here. If I go to event graph, if I want to call this function again, like in 10 different positions, what if it makes better sense for me to call this function rather than creating those 1,000 nodes again and again and again. That's going to look very, very dirty, which is why I'd rather put those 1,000 nodes in one function, and then I can call this function. And delays cannot be added in a function. So if I right click over here, I can just collapse this to a function, and I can say reduce health. And this function, we know that reduces health. If I double click on this, it does the exact same thing over here. Now, if you want, you can convert this to a function too. I'm going to leave it. We've done that for now. We've made functions for we've made a function for reduce health, but I'm going to leave the player death part as it is. But I can maybe add this part to a function. But that just depends on you. Or I can just collapse this to a node. So collapse to node player death. So this basically just it's still in an event graph. It's not a function or anything, but we're just making this part of the code faster. I mean shorter so that we can find out what's going on. Okay. So now let's create a variable called batteries collected. This should be an integer. Why? What we're going to do is we're going to have a maximum number of batteries per level. For example, this level will probably have eight batteries. And once we've collected all batteries, we're going to check if the number of batteries we've collected is equal to the number of batteries that are supposed to be collected. And if it is equal, then we can say the player has won the game and move to the next level, or we can just display a win screen. But in this case, we're going to just move to a new level and you can add all the other functionalities. So once we've reduced health, this part means the player has not died yet, as you can see over here. So what we'll do is, after reducing the health, we're going to check to see if the number of batteries we've collected is equal. But actually, we're not going to do this in the player. We're going to do this in something called the level blueprint. So if I go to my level, if I get a hit on blueprint, and if I hit on open level blueprint, this is a different type of blueprint. It is for the level itself, and it can get access to every single object that's present in the level, and I can add functionality based on that. For example, I can get the character that's present in this level, and then check to see how many batteries he has collected, and check to see if the number of batteries I've collected is um, equal to the number of batteries that are supposed to be collected, and then change to the next level. So let's try to do that. First off, in begin play, we're going to get hold of our BP underscore battery man. So get player character. We're going to cast it to BP underscore battery man. So we're going to convert our character to the battery man, and then as battery man, we're going to promote this to a variable so that we have a reference to our player at all times. And in tick, so now we'll be introducing something else. But before we start making our win conditions, let's actually implement our batteries themselves. So right click, create a new blueprint, and this is going to be an actor, BP underscore battery. If I open this up, I'm going to add something called a box. And I'm just going to add, actually, let me just add a cube over here. If I scroll all the way to the bottom, okay, I'm adding a cube. This is going to be my battery. Your try to change the static mesh to something else. Maybe try to find a battery asset and change the mesh to a battery. But I'm going to leave this as it is. We're gonna scale it. So if you want to scale it, press R. I'm going to make this flat, something like that. Okay, awesome. Now what we'll have to do is let me change the material to maybe I've seen this really cool material that Unreal Engine has. It has this very cyberpunk like texture. There we go. I love this texture. I'm going to make it this. Okay, now if I scroll all the way to the bottom, we have a lot of different events. What these events are is that when the component is hit, do something. When someone overlaps the component, do something. When an object has ended overlapping, do something. So that's basically all these events are. That's what these events do. Let's try to take a look at the on component hit event called when a component hits something solid. So if this component hits maybe something solid like another cube or a player, what is it supposed to do? That's how projectile bullets work in game development too. Let's try to take a look at on component hit. If I click on the plus symbol, I have something called the hit component and the other actor. The other actor is going to be whatever actor that has collided or hit this cube over here, and we're going to cast this to our battery man. No, not the battery man. So search for battery man. Now, if this is true, so if I have hit the battery man, then we're going to get the health, get the battery, and then we're going to add, maybe, let's say we're going to add an amount that, actually, let's make this a random value. So drag a node from this and there should be a node that says random float in range. We're going to add a value between 5 and 10. So this is going to return a value of 5 and of a random number between 5 and 10. And from battery, we're going to set battery again. And then we can drag this in. Now, if I compile and save, let's see if this works. And I have to obviously destroy this object because I don't want to cheat. So I can destroy the actor, which means it's going to get deleted from the scene. If I place this object over here and move this to the top, maybe we can add some light to this. But oops, okay, I have to make sure the game isn't that difficult for me. So I'm going to change my battery value back to 100. Compile and save. Alt P. If I move towards this battery, you can see that my health has increased over here. Let me show you again my battery. So you can see it's slowly increased, which is what we're going to do over here now. We're going to make sure we keep increasing our battery for our player over here. Let me go back to my BP underscore battery. Let me add a light over here, so point light. And make sure you raise it to the top, because if it's inside the object, you won't be able to see it. And we can make it red in color. Okay, compile and save. Now, here comes the interesting part. This is where we make our win conditions. So over here, once we've added health, okay, how do I keep calling it health? Once we've added battery to our battery man, we can add a variable to the batteries the player has collected. So again, get the batteries collected over here. And we obviously have to set it too. So set batteries collected. I hope this doesn't get too confusing. If you do, then try to do a little bit of math in a different project on your own by getting values from a player and casting them, and you'll be able to understand them in no time. I'm going to add 1 to the number of batteries collected. So if let's say I have 3 batteries already collected, I'm going to add 1 to it, so that's going to become 4. I'm going to set the batteries collected, and then I'm going to destroy the cube. Compile and save. Now, in my level blueprint, I have to make sure I define what is the maximum number of batteries, right? So let's try to do that. Now, right click, we're going to take a look at something called the game instance. So let's take a look at game instance over here. Now, gi underscore battery man instance. We're just going to call it that. So in this instance, what a game instance is that it is an object that persists through every single level. So this object will be there in the main level, in level 1, level 2, level 3. This is going to persist in every single level. So we can add a few variables that says, okay, if it is level 1, then make sure the number of batteries is, let's say, 8, and in level 2 it has to be 10, etc. Now this is not the best way to do it, but since this is a very beginner level tutorial, we're not going to go over gameplay, like proper gameplay mechanics. So I'm just going to add a variable here. So level 1 win batteries. Actually, no, max batteries 1. So this indicates for level 1, this is the maximum number of batteries. We're going to make it a float, and let's set this value to 8. Now, if you want another level, let's say level 2, you can say max batteries 2, etc. Now go to the level blueprint, and you will have to do this for every single level. But in tick, what we can do is we can right click, get game instance. We have to cast this to our battery man instance, cast to GI battery man instance. And again, we can do this in begin play because we don't want to cast this every single frame. And then we can promote this to a variable, GI battery man. Okay, now from the battery man instance, what we can do is we can get max batteries for 1. And then from our battery man, the player itself, we can get batteries collected. We're going to check if these are equal. Now I forgot to make this an integer. So let's make sure this is an integer. Compile and save level 1. Let's check to see if these are equal. So if these are equal, then I can basically say, so again, we have to create a branch. So we're creating a condition over here. So if we create a branch, event tick, if these two are equal, then I've won the game. So I can just end up opening the next level, or again, I can have a win screen or whatever. We're just going to open another scene for this one, and let's call this level the next level, whatever. For example, this one's going to be level 2. You will have to do this for every single game level. But remember, in the C++ course, since that's going to be a more advanced course, we'll take a look at how to make this a lot more scalable, in the sense how to make sure we just add the logic once and we don't have to keep copy pasting our code on and on and on. Now that we've created the game instance, we have to make sure we set it in our project settings. So go to Maps and Modes, and if you scroll all the way down, our default game instance has to be gi_battery instance. Let's create another level over here. So again, new level. This is going to be a default level, and save it. We're going to call this level 2, and that's pretty much it. We're done with all of our core mechanics now. If I play the game, and let's say our maximum is going to be 1. So if I open up my game instance over here, my maximum number of batteries is going to be 1, for example. Save the game, and if I play now, we now move to the next level. So that's how we make our win conditions. Now all you have to do is decorate your level, maybe add a few obstacles and maybe like a few cubes that distracts the player. Maybe try to make this into a maze. Get a few assets from the marketplace and try to make it in such a way that maybe it's like in a spaceship and the player has to find all the batteries from the spaceship, which would probably look really, really cool. But now I have 5 different batteries here. So I'm going to go to my game instance. Maximum batteries is going to be 5 over here. Compile and save. Oops, and save it. Okay. Now let's see if this still works. So Alt P. I'm going to collect. Oops, it seems like I have to make sure this is all the way to the bottom. So all the way to the bottom, all the way to the bottom. Okay, Alt P. Now let's see. So first, my battery does keep increasing, so that's pretty cool. But okay, I might actually lose this. I'm not really good at games. Okay. Okay, we seem to win the game. That's awesome. And yeah, that's pretty much it for our win events. Now, let's say your level 2 is your last event. What you do is in your level 2 level blueprint, so if you open up level blueprint, just have the same condition that as you had in level 1, except if it's equal, you create a new widget, your win screen, for example, and then you display that win screen onto the scene. For example, if I go to level 2 now, let me actually show you how to do it real quick. So if I go to level 2, open my level blueprint. Now again, try to do this on your own. Please don't try to copy whatever I'm doing. That's why I don't want to show everything, because I want to sort of make sure you guys get it on your own. What you'll do is you will get your game instance again. You will cast this to battery instance. And we're pretty much doing the same thing we did before. And remember, if you have level 2, your level 2 level blueprint open, you can't open your level 1 level blueprint. It's going to get closed automatically. So we're going to promote this to a variable. And same thing. The same thing happens, except it's going to be for our player character. So get player character, cast to battery man. So basically converting it to battery man, and then promote the variable. And then we can get max, get batteries collected, and we can use this to compare. So in our event tick, what we'll do is we can get these two, get batteries 1. So there's going to be, so we have to create a new condition for level 2. So all you have to do is Control C, Control V, rename this to max batteries 2. I'm just going to make sure the max battery is just something low like 1 for my level 2. So if this is equal to the number of batteries I've collected, not battery, number of batteries collected, batteries collected, awesome. If this is true, what's going to happen is I can just print out. I can create a new widget. There's going to be my win screen over here, which is going to basically going to have a text that says you win the game, and then it's going to have a quit game. And then over here we're going to say cast to, add to viewport. Now if I try to compile, well, it has an error over here because the create widget class has to be specified. So let's create a new UI element over here. So UI, actually, let me duplicate this. WBP underscore win screen. Now instead of lose, we can just say you win. And we're going to load out, for retry, we'll load the first level. And actually, let's have the return to main menu part in this. Main menu. And in quit game, yeah, quit game is going to be the same. Now in the graph, open level for, we have to make sure we rename everything because we just duplicated it. So for retry game over here, we have to make sure this says main menu now. It's just for simplicity's sake. Now, when you press the main menu, we want to open up the main menu. So we're going to create a new level called main menu, obviously, compile and save. Because if I go to level 2, I can just create the win screen and make sure you get the player controller. So get player controller, show mouse cursor. We're going to set it, not get it. So show mouse cursor set it. We are going to set this to true. Compile and save. Now we have the main menu. We have the main menu part, and that's pretty much it. So my condition for my second level is going to be 2. So I just need to collect 2 batteries and I win the game. So over here, we're going to end up adding batteries again. We'll add 2 batteries. If I play the game now, collected 1, collected 2, and doesn't seem to be working. Let's take a look at what's going on. Okay, the reason why it wasn't working was because I got the variable for the first level. So we're going to get batteries 2 over here and make sure we set that. Now it's going to work. So if I compile and save, and again, remember, we have to make sure we detach from, okay, if I go back to my battery man, you see we have detached from pending destroy over here. We're going to do the same thing over here. That's because as I move my mouse, I don't want my camera to move too in my win screen. So let's actually see if we can get this on our own. So detach from, nope, I'm not able to get that particular node. So let's see if that's present in our player controller. No, it's not present in our player controller, which means it should be present in our character himself. Detach from controller pending destroy. There we go. We can do that. Compile and save. So this means we cannot control our player anymore. So once I collect these 2 batteries, it says you win. And again, one more problem. This is going on in tick. So we have to make sure we do this only once. We don't want this every frame. It's going to crash your game, which was about to crash my game. So we have to make sure that's done only once. If you want, you can put all of this in a function. And yep, we're going to save this. go back, Alt P, collect the first one, second one, we win, quit game, and we're done with the game. Awesome. Now, obviously, this is not the best way to make a winning condition, but if you want to, don't worry about making it the best way possible the first time you're trying it. The main point is to understand how blueprints work first, and then in the next course, which is why the next course is going to be a more advanced course where we'll be learning proper winning conditions, all gameplay principles, etc. Now, we have one more thing remaining, and then we're finally done with this course, which is going to be our main menu. So if I have to create another widget blueprint, wbp underscore main menu over here, and I'm going to add an image again. Let's make this full screen and anchor it, make sure that's full screen. And now what we're going to do is, well, let me change this to black first. We're just going to have two buttons. One is going to be play game, one is going to be quit game. That's pretty much it. And I'm pretty sure this is self-explanatory. I'm pretty sure most of you guys will be able to do this on your own by now. But if not, no problems. Don't feel demotivated. It's completely fine. It's normal. So we're going to say play game over here. Duplicate this, control W, that's duplicate. And oops, there you go. We're going to make this, we're going to call this quit game. And obviously you can have another button that shows the controls, etc. Over here, let's add some text. Text to both play game and load game. I added it to the image by mistake, so I'm going to remove that. This is going to be called play game. This is going to be called load game. And obviously we want to change the size to like maybe 34. That's not going to be play game, it's going to be quit game over here. And over here, again, go back to the font, make this 34, compile and save. How do we tell the editor that whenever we open up our project or the game, we need to make sure it opens this main menu level? To do that, go to Maps and Modes, and you can see your editor startup map and your game default map. What I'm going to do is I'm going to create a new level and make sure it opens up the main menu over there. Now, open up a new level. Actually, we don't need to make it a default level. We can just create an empty level over here. And Control S. You can see that's completely dark because there's nothing in this level. We're going to call this the main menu. Over here, what we're going to do is open up your level blueprint. Before that, we have to add a game mode override because, as I said, it doesn't have to add. So if I run this game now, it's going to, okay, Alt P. You see it spawns the BP underscore battery man. We don't want that, obviously. So what we're going to do is we're going to add a game mode override over here, which means for this level alone, it's going to create a different game mode and it's going to use that. So under custom blueprints, I'm going to create GM underscore main menu. And over here, under default pawn, it's going to be none. Under HUD, I'm just going to have all of this normal. Now, under blueprints, open level blueprint, again, we're going to do the same, except this is going to be in begin play. So create widget, and what we're going to create is the main menu and add to viewport. Compile and save. Now, if I go back to my project settings, if I scroll down here, I have my editor startup map. I'm going to keep my level selected over here. So content, levels, main menu. I am going to hit this arrow and it's going to automatically assign my main menu. Now let's play the game. So if I press play game, nothing happens. That is because we haven't added functionality yet. So if I go to main menu, select this button again, scroll all the way to the bottom, on pressed, you know what to do. Open level. This is going to be level 1. And if I go to quit game, on pressed again, you can just quit the game. Now make sure in our in our windscreen level blueprint, the level is named properly. So that's main menu without a space, compile and save. And let's just have a simple playthrough now. So if I Alt P, play game, I have my HUD, and you may not be able to see because of that. Okay, there we go. We're going to try to collect all of these on time. And that's level 2. In level 2, we're gonna get these two, and now we win the game and we can quit the game. That is pretty much it. Now we have a tiny little bug over here. The animation keeps playing for our in our level 2 after we win the game, because we haven't added a win condition in our animation blueprint. So what we're going to do is we're also going to add another variable, and this variable is going to be called b as player 1. Now in begin play, I'm going to make sure I set this value to false and make sure this is a bool. So we're going to change variable type, close, compile and save, and make sure we set this to false every single time we start playing the game. Over here in my level blueprint, again, what I'm going to do is in level 1, let's save selected, blueprints, open level blueprint, and we have to make sure we get this character from the character over here, set player 1 has player 1 over here. If it's true, then we have to set this only in level 2, not our level 1, because our player hasn't technically won the entire game completely yet. So if I go to level 2, open up my level blueprint, I have the same thing over here too. Now if I from the battery man, I have to set 1, just search for has player 1. I'm going to double click on this node so that I can redirect this node over here like that. Move it all the way to the end and then connect this. We're going to set this to true. I'm going to again add another node over here so we can direct it properly so it looks a little neat. Compile and save. Now let's open up our animation blueprint. I'm going to open that up. Okay, over here now we're blending spaces. We're blending poses by bool over here. Now, if player is dead, we're going to play the idle animation. But if the player is dead, or if the player has won the game, we're still going to play the idle animation. So over here, we're going to have an OR boolean. What this does is it checks if one of these bool. So it takes in 2 bool values, and if it can obviously take a lot more, it can take 5, 6, etc. But we just need 2 of these, so we're going to remove pin over here. If the player is dead, or if the player has won, play the player dead animation. So to get that, cast to battery man, we've already done that. From here, we will get 1 has player 1. Move this all the way to the bottom, and again, we're going to promote this to a variable. The name is fine. And all the way to the end. There we go. That looks a little neat. Anim graph. Place this over here. So if any one of these conditions are true, we're going to play the idle animation. So if I now play the second level, 1, 2, see now my animations don't play continuously, so I can now quit the game, and that works perfectly fine. Awesome. Now that is pretty much it for this game. your challenge is to add your own map, try to add your own level, go to the marketplace, there are a lot of free assets that you can use. Maybe make this into a spaceship and try this out. The only problem now is that, unfortunately, since Unreal Engine 5 is still under development, most of the assets are not compatible with the engine. So if I go back to my Epic Games launcher and if I try to add this free asset that I got from the free for the month thingy, if I click on show all projects and try to select Unreal Engine 5, you can see it says asset is not compatible. So what you'll have to do is you'll have to downgrade this project to Unreal Engine 5, and then you will have, Unreal Engine 4, and then add the assets. But the problem is you might have a lot of issues after upgrading it back to Unreal Engine 5, which is why it is still in early access. Not a lot of assets are still are available for Unreal Engine 5, which is, yes, it is a little disappointing, but at the same time, they've specifically mentioned this engine is in early access. So don't be too worried. You can follow the exact same tutorial that I've showed over here in Unreal Engine 4. It's the same functionality, same blueprints, all of them work perfectly fine. It's just that the UI might look a little different. This looks a lot more modern than Unreal Engine 4. That's the only difference I could pretty much find for now when it comes to at least the basic parts. So this tutorial can be followed in Unreal Engine 4 too, so don't worry about that. But thank you so much for watching. I really hope you learned something and I hope you were able to familiarize yourself with Unreal Engine 5 and game development. If you completed this course, that is amazing. Try to add your own functionality to it. If you want to learn C++, stay tuned because I have a C++ course coming very, very soon. We're going to create the exact same game but in C++. So that is going to be very, very fun. But thank you so much for watching, and I will see you very soon. Bye bye, and good luck.